guess I don't need to talk about myself. Femi has already done. Well, there's nothing else to add to that. Femi is citing me in the background to not to hang on. I'm trying to get this. Okay. All right. We've got it. Good. Good morning, everybody. Oh well, it's afternoon. Good afternoon. So before I start, I just want to get a feel of the room. How many of us are developers? Okay, no, let's do it like this. Stand up. Let's also stand up. Haven't been sitting for too long. Let's all stand up. Alright, so I'll ask it like this. If you're not a developer, sit down. Okay. If you are not a DevOps engineer, sit down. Okay. Because two friends. Alright. Oh, you're sitting down. Alright, okay. Sit down, sit down. I just wanted to get a feel of the room so I would know how to channel whatever it is I'm saying and not speak Greek, instead speak English. Well, like Femi said, I've been doing this for about 18 years. Actively been doing DevOps for about 5 years now. Well, to be honest, I've been doing DevOps for much longer than that, but been doing DevOps in an official capacity for like 5-6 years. But as an engineer, I've been around for about 17, 18 years. So quick tip, if you have a question or there's something that is said that you don't quite understand, it would be a good thing to just note it down, write it down, or if you have your phones with you or your notepads, just write the question down. And then at the end, at least we should have about 10, 15, maybe even possibly 20 minutes to be able to cover whatever questions that you may have as respects to the presentation or even anything else in general. Since I'm here, I want to keep my brain. I'm also open to that. Okay, so different question. Most of us started coding, what, maybe 5 years ago, the last 5 years, last 3 years. Anybody here who started coding like 8 to 10 years ago? Anybody in the room? You did? Okay, so I won't say you're ready, but been around for some time, I think. So yeah, we're in the same category, I've been coding for a while. And how we used to develop applications back in the day and how we develop applications now is totally different. In fact, I dare say, how we used to develop applications in January is different from January 2018. It's different from how we develop applications. This is December 2015. The point I'm trying to make, if you're, for example, in the JavaScript community, a whole lot has changed and is changing. And it's a good thing to find a way to keep up with the times. So as with developing applications and trying to scale infrastructure. So what I'll be trying to share today is, okay, you've built an application, you built a front-end application, you built a back-end application, back-end API. How do we get it into production? And then how do we keep it running optimally? And how do we scale it if the need arises? So you work for XYZ company or ACME company, and you built an API that takes an image and converts it from JPEG to PDF, for example. And you launch the service, and the service does wonderfully well. From day one, you had 100 users, and then by day 2, you had 800,000 users. How do you stop or keep that application from crashing? What are the steps you should take in order to avoid things like that happening? That's the essence of what I want to be sharing today. So in order to do that, I want to talk about where we are coming from and where we are now and where I think we should be going to, right? Now, on the left, this is typically how applications used to be built back in the day. Startup, you had one server, all right? I'm sure you remember this period where I'm sure some of us are probably still doing it. We all know what VMs are, right? They're all virtual machines. So you get a virtual machine from HostGate or DigitalOcean, from Femi, help me with some of those old guys we used to use back in Rackspace. Yes, they're still around. Don't get me wrong. It's just you get a VM installed. If you did PHP, you install your maybe Apache server, WAM server. If you did Java, you install the Java JVM there. If you did .NET, you probably didn't have VMs. Well, there's Azure now. What other language was there? Well, there were quite a couple of them. Now, what we used to do was we take the database, put it on the server. We take the application, put it on the same server. We take the front end, if there's any, put it on the same server. You can imagine what a calamity that is. If that server goes down, everything is gone. But that was how we used to do it back in the day. And back in the day, it could still be present day for some people, right? Which is why we're having this conversation, so that guys like us can now start to change that time. On the left is you had all the dependencies and all the things and everything that you needed for that application to run will be hosted on that single server. We're not even talking code base now. We're just talking the different layers, which is back end, middle, front end, right? If I'm trying to simplify it in the best way, that's what it used to be. But jump into today's world, right? On the right, you can see, even though it looks scattered, it looks chaotic, doesn't it? But that's organized. Well, I won't say chaos, but it's organized in a way. The reason why is this. Take this Node.js application, this blue dot, for example. If everything inside this ecosystem is what needs to make your application work, right? Just like on the other side, I said, you have your Nginx, you have your Java, you have your MySQL database, and so on and so forth, for the whole application to work, right? If this was the scenario, if your Node.js bit or service goes down, at least you just have partial outage. The rest of your system will still functioning normally, because your Node.js server is on its own small, well, for lack of better words, right now, VM, or its own container. We're not talking about containers, but let's just imagine we had this big server, multiple of it, and each of those servers now had just the thing that we needed to run, which was, in this case, say Node.js, Python, Java applications, and they all were running on their own. What would that mean is that if that server should go down, right, the whole system won't be affected. Only that part will be affected, which means you have much more higher availability, the system is much more reliable, and you can quickly fix only that part. You don't have to, tamper with the whole system. I remember back in the day, you wanted to do a deployment, and you did one deployment that affected one part. Just because it affected one part, the whole system will go down. That's what will happen on the left. This is how we do things today, or this is how we advise that people should do things today. So this is the before, and this is the after, or this is the now, and moving forward. Right? More detailed approach. So I just explained the monolithic approach, which is application 1. You can see on the left diagram 1 and 2, where you had, yes, another thing I wanted to know, which is what I'm replicating here. If you wanted to achieve high availability, which is so you have one server. We talked about one server in the previous slide. So how would you typically, previously, in the older days, make sure that that system is highly available? You would replicate the whole system, duplicate it, put it in another system, duplicate that one, put it in another system, and then put a load balancer in front. So technically, you would probably have maybe 3 databases, 3 APIs, which is standard, but the only difference is you're paying for server costs. So it's all the dependencies and everything that needs our application to work on one system multiplied by 3. Right? That's what we used to do. But these days, you might not need to scale the parts that has to do with Node.js, because maybe the only time it will actually ever be active is 1 minute in the whole life cycle. Right? Meanwhile, there's another part of the application that is always active 99% of the time. And then, in this case, you've replicated the whole system. What does that mean? You are wasting money on that 1% that you are only using 1%, 1 minute of the time. But with a new system, you can decide that, okay, it's the only Node.js application that receives a lot of traffic that I want to scale out. So you can then decide that you can replicate only that bit, and then leave the ones that need less or have less attention, and then you only scale them maybe just to 2 nodes or 2 instances, while the other ones that need more, you can scale out more. That way, you optimize your resources, you save money, your spend is less. Am I making any sense? Yeah. All right, so that's the typical difference between the microservices architecture and the monolithic approach. Now, when developing, or when trying to reach out for the microservices pattern. I don't know, I didn't explain what microservices are, did I? Did I? No? Okay, so essentially, microservices are small bits of isolated functions. So think about it as, bits of, I don't want to say code, but for lack of better words, a service. So let's say a service, all it does is take one input, transcribe or do something to that input and give you an output, right? That small unit in itself could be called a service. That service is part of a larger application, and the application is probably a combination of multiple services. This is the best English version I can say without being too technical, right? So think of microservices as smaller, isolated bits of code that run on their own, managed and maintained and deployed on their own, independent of other services, right? So the existence of the lifespan or the life cycle of one service is totally independent of the next, unlike monoliths where it is dependent. So you can't make a change to one without making a change to the whole sum of the system. So that's since I've explained that, I can then talk about factors, the 12 factors. 12 factors are guiding principles that help with the microservices pattern. Okay? They're quite straightforward. The website is there, 12factor.net. Okay? 12factor.net gives you all the information you need, all the guiding principles. You know what are they? Your code base should be in a repository, right? Your code base should be in a repository. You should use something like GitHub, Bitbucket, GitLab. How many of us know at least GitHub? If you don't know GitHub, raise your hand. Again, you don't know GitHub? You know GitHub? Why did you raise it? I said if you don't know GitHub, raise your hand. Okay, that was scary before. So you have one code base which is tracked in revision, and you can deploy that code base over and over again. Who remember those days we would zip up our code base and then FTP it into the VM and then unzip it there and then deploy. Those were the fun times, eh? Fun times. You still do it?
No, cPanel.
cPanel, yes, cPanel. cPanel, yes, I'm sure brings back fun memories. Fun memories. Okay, so the number 2 is dependencies, right? What are dependencies? Dependencies are the things that your application needs to run. So let's say it was a PHP app. For PHP app, let's say it was a Laravel app. At least most of us know what Laravel is, right? What are dependencies that Laravel needs to run? You need PHP installed. You need one or Apache with Nginx, so you need Apache or Nginx to run. You need all the composers, you need PHP extensions, enabled, all of that. Those are all dependencies. Before, what you would do would be you would configure those dependencies on your VM directly yourself. But with the 12-factor principle or methodology or idea of thinking, it's saying you should declare those dependencies in a format that allows you to keep them isolated. Am I making any sense? And a good tool to help you do that is something called Docker, which we'll talk about later on. So you should actually declare and isolate your dependencies. What I mean is, don't go into your server and start installing your dependencies manually. You should be able to declare them somewhere where the system can install it for you automatically, right? That way, that software is repeatedly installed somewhere else if you have to change the environment and so on and so forth. All right. Configuration. Store your configuration in your environment. Yes, there are many culprits in this room, myself included at some point, that we used to keep the secrets inside the repository. How many of us have done it before? Don't be shy. Yeah, Femi, you are part of us. So I want somebody to
No, everybody has.
Nobody. So you are all.
Everybody has.
Everybody. So why are you making me feel like as if it's just me and Femi that have done this mistake before? It happens mostly in PHP, right? You keep the MySQL password and the MySQL username inside the code and say, no, you shouldn't do that actually. You should keep your configuration in the environment variable. It's a standard rule now with the 12-factor. All right. So treat your backend services as attached resources, okay? Like, remember again I talked about monoliths where you had your MySQL database on the same server with your application. To treat it as an attached service, it means you will take MySQL out, for example, put it somewhere else in a server, and then have a connection via HTTP or HTTPS or TCP, right? That instance, and that's the same guiding principle that you should have for all services. Okay, it's not compulsory that a third-party service that you're using within your application must live inside your application. Right? If you can have a remote connection to it via TCP, HTTP, or HTTPS, that's a better way to roll it. And it's a guiding principle. Why we're talking about it now because it affects not just the way you develop or the way you code, so that affects how you deploy them, which is the DevOps part of things. Right? Build, release, and run. Right? Build, release, and run. So essentially, you have to have pipelines, development pipelines. So you have your so typically you have staging, you have production, and you have your test environment. Right? Reason why you should have staging. Staging is the staging area of code. This is when you keep this code that you have, your products that you build, the front end, the back end. This is where you keep it first and you test it. Alright, you test to make sure that it's working. You don't just send it to production straight. The reason why is in case there's a bug, in case there's a mistake, in case there's something off with it, it won't be live users that will be experiencing it, right? Current, companies like Google and Microsoft and Facebook, rarely do you find where a bug gets to production, which is the products that's used like Instagram and Twitter. Rarely do you find bugs there, do you? Has anybody ever experienced a bug with Twitter, Facebook, Instagram? If there's anybody, please tell me. I haven't experienced it, right? And the reason why is because they have these kind of principles, guiding principles, in the engineering process, right? So you build it, you test it, and you stage it, and then you test it. You keep testing and make sure that everything works okay and it passes. Then you can say, okay, it's time to go to production. You don't just build and then ship to production, right? That was how we used to do it in the old days. But now with 12-factor guiding principles, you shouldn't do that. Okay. Processes, execute the app as one or more stated processes, right? Port binding, export your services via port binding, concurrency, scale out the process model, scale out via the process model, disposability, yes, maximize robustness for fast and graceful, fast startup and graceful shutdown. Some of these things I just talked about, right? They might seem like, high level, Greek, what have you. But to be honest, there are tools which we'll talk about that would help you, fast track some of these things. Okay, I talked about Chuka, one of them. Another one of them is Kubernetes. These are tools that help with some of these guiding principles. So these principles are not they're a guide. And to be honest, it's not like we're saying it's compulsory. You must follow them to the letter. However, there are tools out there that will help incorporate some of these guides, some of these guiding principles, so you don't have to worry about them. You don't have to go and implement your own, for example, build system. You can just take one that already exists, like Travis or Jenkins or what have you. Dev and production parity. That's number 10. It's a simple principle. It just means your development environment. Okay, how many of us have experienced this? It's working on my system, but it's not working on the server. I'm sure all of us have experienced this before at some point or the other. One of the guiding principles for 12-factor is to say that your development environment and your production environment and your staging environment and your test environment, no matter how many environments you have, should be all the same. They should be the same. The minute you make it the same, it makes it easier. You know why? Less and less of it's working on this environment and it's not working on the other. Okay? And the only way you can achieve that is if, for example, you isolate and declare your dependencies. So which means you don't have to manually go and install dependencies of dev and manually install dependencies of production. If you can automate that, what will happen is dev and production will be easily. See, part of the problem is the things to get achieve some of these principles. How to do it manually, the stress that is involved is why people sometimes avoid it. I mean, outside of know-how, in case they don't even know how to. Right? But again, I'm saying that there are tools and there are frameworks and there are languages or there are products out there that can help with some of these issues. Okay, and the last two are logs and admin processes, right? Treat logs as event streams. Logs are probably one of the most important bits of your API or your front-end application. If your application is going to have a problem, it will be seen in the logs. There are those kind of problems that probably happen in the UI, but did not happen to you. It happened to another user, and the user didn't complain, but he's experiencing the issue, right? How do you know? Check the logs. There's almost all applications have logs. I don't even know if there's an application that exists that doesn't have logs. All right? Logs are event streams. You need to, from time to time, keep track of them. Now, if you're not the designated person in your company or the environment where you work, the DevOps person or whoever is in charge of infrastructure or release should be the person who is responsible for that. But it needs to be monitored. It's important. That's part of the guiding principles of using a microservices. Right. Admin processes here. So you run admin processes as one-off tasks. What are admin processes? Things like, okay, for example, you're deploying a new API and you should ship with a, say, for example, a default user, a default admin user painting, or you need to provision resources. You only do those kind of things once. Those things that you need to do once, do them once. All right. So, what is the major? What would be the major thing that would help you in first of all achieving 12-factor one, and in being able to realize a microservices pattern? Automation. Automation is the major thing. So, what's automation? I think it's quite simple. Getting a machine to do something that you would have done normally. That is all automation is. I tell you, the minute you are able to automate bits of your process, bits of your code, you will find out that you will free up a lot more time for yourself to either invest in your product, invest in whatever it is that you're doing. If you're building front end, you're building back end, whatever it is you're doing. If you automate, you would have, in fact, you have a longer life expectancy. I guarantee you that. So, what are the major phases of a deployment or infrastructure pipeline? Right? You develop the product or you develop the code. So, with the languages we know there, I hope I didn't miss anybody. This is most of the economy, the community right now. Node.js, C#, Python, Java, React, Go, HTML, PHP. Did I miss anybody out? Is anybody not on the wall? Okay, I think I got everybody. All right. You integrate it, which is what we know today as continuous integration. All right. You've heard that buzzword before. Continuous integration, continuous deployment, CI/CD. Right. Integration is simple. It's the process of continually making incremental changes to your code. That's all that it is. So if you've ever made a commit before and your commit got to production or got to staging, that process is what we call integration. You built something new, you added a new feature, you integrate it. These are some of the tools that help with integration, which is what I talked about, right? Remember first point on 12-factor app, which is code base. You should continue to put your code base in revision. You have GitHub. Git itself is the foundation. So we had Git, we had Subversion, I think. We had CSV, and we had at some point, I think Mercurial. Mercurial. Yeah, I never used Mercurial. So I used Subversion once, but Git is what I think a lot of us use. Is there anybody who doesn't use Git? Doesn't. Okay. So some of the platforms built around this technology: GitHub, Bitbucket, Google Cloud. Google Cloud has source repositories. GitHub, github.com, and then there's GitLabs, which you can use in the cloud or host yourself. There's Bitbucket, which you can use, Bitbucket Cloud, and then Bitbucket's server, which you can host yourself. So depending on who you work for, if you work for a bank, most likely they want on-prem. If you work for yourself or you work for a startup or a company who's not very enterprise, you could use any of the cloud versions. There's the free, and then there's the paid. Okay, these are the public. You can Google them, find them. Build and test. See, this blue column is probably one of the most important bits in terms of automation in the development pipeline. All right. How do you get your software into staging? How do you get your software into production without much stress? I know at some point in my life, every time a new feature was built, I have to log into the server, SSH in rather, go into the folder where the code is, do a git pull. After doing a git pull, restart the Node.js application, and then go and test the endpoints to see that it's working. I had to do that every time. So the disadvantage was that it limited how many times I could release new changes, because when I think about the stress of making that change, and then sometimes I have to do that change like 2 a.m., 1 a.m. when nobody is active, well, at least in Nigeria, in Africa, when nobody is active on the portal, so that I don't have as many issues or broken connectivity, as less problems as possible. But when you have tools like this, so you have Jenkins, you have CircleCI.com, you have Travis, you have Bitrise, there's a host of them, all right? These are just some of the ones, my top picks, right? These tools, once you configure them, they will go and do these things I just explained. The manual, SSHing and all of that. These tools will help you to automate that process. So it is lovely when you do a commit, all right, and you finish your code, you do a commit, you push your repository, you create a PR. Once you create your pull request, your manager or line manager approves that pull request, and your pull request goes into the build pipeline. The system or a machine takes our software, builds it, installs the dependencies, configures it, and then checks it to test it to make sure that it's working. Once you check it to make sure that it's working, it says, okay, this is okay, it's green, and then it sends it to staging or production, rather than you doing that manually. So once you make your commit, all you have to do is sit back, fold your arms, and relax, drink some tea, and then you wait maybe 10-15 minutes, depending on the kind of project it is, and it should automatically get into production. Okay? But in order to be able to use some of these tools, like at least for the first few stages, there's also parts of process that needs to be involved. You need to have a good project management tool that you can use. There are also project management frameworks that you should be able to incorporate, which Agile, Scrum, it's a good form, at least in today's world. There are many other ones. There's the waterfall model, which most people don't do. I think that's very enterprising. You have to define everything before you start. But in an agile, in the world today, it's usually very agile. You think of features, you scope them out, in another 2-3 weeks you're working on it, and then you ship it out. That's the way we work these days. So you need good tools for project management. Jira is one of them. GitLab is also one of them. Trello is another one that can help. These are tools that can help working with these products that you see on the screen. And then the final phase is the deployment, right? Deployment, right now, talked about monoliths, we talked about VMs, and how we used to get our software onto VMs manually. So since you're going to automate that process, that's the section for deployment. These are some of the great tools that can help as part of automation. Okay, because everything's like Lego. Okay, if you pick the right set of tools, you can automate and link everything together and form a pipeline. That's actually what a pipeline is. So these 4 bits, this is a pipeline. You build the code, you integrate it. You develop the code, you integrate it, you build it and test it, and then you deploy it. Some of the great tools that you can use for deployment: Kubernetes, Docker, OpenShift, Amazon ECS. They also have Amazon Container Service. There is Amazon Community Service now that they launched recently. There's DigitalOcean Community Service, which was launched as well. There's Mesos. So these are some of the names. Okay, I put most of the logos on there so that you can Google and research and pick up material. I don't know if we have. Do we have resources on communities right now? Do you have any resources on communities? Okay, I know YouTube I have, so we could share some of those. That's that. I have a favorite quote. This is a tip, right? I always say this at almost all the speeches I give. always cool as if the guy that's going to maintain your code is a psychopath that knows where you live. So if you code rubbish, you come and find you in your house. It's just a fun thing. Don't mind me. So DevOps, CI/CD. I talked earlier about some of the tools that are in this ecosystem, and I already mentioned that the bane of microservices pattern, the mean of being successful at it, is automation. If you cannot automate it, then you'll be frustrated. It's not, look, the end result is easy and sweet, okay, but the journey there can be quite difficult if, well, let me use the word difficult, just let me say challenging, if what you are used to doing is SSH and git pull and deploy. Now that's quite simple, 3 simple steps. Alright, but then in today's world that's currently changing, I talked about how we used to do things in January and how things are different now. Because the world is constantly changing and we're finding more and more opportunities for tools like this, automation is the way to go. So for continuous integration, which is the process of continually pushing your code into staging of production, these are some of the tools that can help. I talked about Jenkins, I talked about Bamboo. Okay, no, I didn't talk about Bamboo, but there's Jenkins, there's Bamboo, there's Sona, there's quite a couple of them. Different kinds of tools for different scenarios. Most of them do mostly around the same thing. Okay, the most popular I think on this page is Jenkins. I mean, I think for those who do CI/CD, Jenkins is probably one of the most popular because it's free, it's open source, you can host it yourself, you can manage, maintain, upgrade it yourself, you're not paying any licensing fee, and you can have it installed on-prem or in cloud. It's all up to you. Alright. Here's the tip. You don't need to automate everything at once. Okay? You don't need to automate everything at once. I didn't say now because we're giving this talk and I'm saying automation is the way to go. You now go and shut everything down and start automating. No, that's not what we're saying. But we're just trying to give you the methodology and the thinking and the idea behind it so you can start taking it one step at a time. So maybe the first thing you might try to do is if you had a front end, a back end API, a database, some small jobs or cron jobs that run, maybe start with the front end. Try and automate,